Hi, this is Warren. Welcome back to Coffee One Roast at a Time. This channel is simply me documenting my journey learning to roast coffee at home on the Gene Café CBR-301. No hype, no shortcuts, and definitely no claims of being an expert. Just real roasts, real observations, and the occasional mistake along the way. If you're interested in home roasting, understanding how coffee behaves, or just curious about what actually happens inside a small drum roaster, you're in the right place. And if you enjoy this kind of honest, experience-led content, please consider liking the video and subscribing. It really helps the channel grow and helps more home roasters find these experiments. In an earlier video, I tested whether the Gene Café could produce consistent roasts back to back. And interestingly, it could. But that left me with a big question. What actually happens between roasts? Because once the machine is hot, everything changes. So today I roasted 4 batches again, but this time the goal was different. I wanted to better understand what happens when the machine never returns to a cold start. In other words, what I'm calling the between batch protocol. So with that question in mind, I decided to run a simple experiment. 4 consecutive roasts, same coffee, same batch size, same machine settings. The only thing that would change was the starting temperature of the roaster. Because once the first roast finished, the machine never really returns to a true cold state. There is heat stored throughout the system, inside the roasting chamber, inside the airflow path, and inside the internal structure of the machine itself. So each new roast effectively begins with a warmer machine than the previous one. And I wanted to see whether that would change the outcome. To keep things as controlled as possible, every batch followed exactly the same process. Each roast used 250 grams of the same green coffee. The machine was set to 250 degrees Celsius, and the goal was straightforward. Try to produce 4 roasts that finished at roughly the same roast level, even though the machine was getting progressively warmer. Rather than focusing on flavour notes or trying to interpret crack timing, I looked instead at a few simple markers in the roast data. Points that are easy to observe and easy to compare across multiple batches. The first marker was the time it took the roast to reach around 200 degrees Celsius. On the Gene Café, this is also the first moment where the machine asks you to confirm the roast is progressing normally. In many roasts, this roughly corresponds to the end of the drying phase. The second marker was the time the roast reached around about 230 degrees Celsius. At this point, the browning reactions are well underway and the roast is moving deeper into development. The Gene Café also requires another confirmation at that point. And finally, I looked at the total roast time, the moment where cooling is triggered. Together, these 3 markers give a simple way to compare how each roast progresses. What surprised me most was how similar the roasts were. Even though each batch started with a warmer machine, the key milestones stayed remarkably close together. The time to reach 200 degrees, the time to reach 230 degrees, and the final total roast time all landed within a relatively small window, which suggests something that's quite interesting about how the Gene Café manages heat internally. The roaster seems able to absorb and redistribute heat in a way that keeps the roast surprisingly stable, even when the starting conditions change. Another detail that appears consistently in the roast data is the behaviour of the fan. At roughly the same stage of the roast, the airflow increases to fan level 3. This appears to happen around the early to mid phase of the roast. That airflow likely serves two important roles. First, it helps to protect the heating system as temperature rises. And second, it helps remove moisture and smoke as the beans begin releasing gases. In other words, the machine is actively managing its own thermal balance during the roast. And importantly, this behaviour appears consistent even when roasting multiple batches back to back. So what does this mean in practice? If you're roasting several batches in a single session, the most useful approach seems to be keep the routine between roasts simple and consistent. Allow the machine to complete its cooling cycle, remove the roasted beans, clear the chaff path if required, weigh and reload the next batch, and start the next roast without trying to artificially reset the machine temperature. The roaster appears to handle the thermal balance quite well on its own. One thing I'm beginning to explore further is whether the starting temperature of the machine influences the total roast time needed to reach the same roast level. It's an early observation from this experiment, but it's something I want to validate across more roasts before drawing any firm conclusions, because understanding that relationship could make batch roasting even more predictable. For me, this experiment highlighted something important. Consistency when batch roasting isn't just about what happens during the roast, it's also about what happens between the roasts. And the more I use this machine, the more I realise the engineers seem to have thought quite carefully about how it manages heat internally. If you're roasting on a Gene Café as well, I'd genuinely be interested to hear your experience. Do later batches seem to finish faster for you, or behave slightly differently? Because the more observations we share, the better we can understand how these machines actually behave. No shortcuts, no hype, just learning, one roast at a time. Thank you so much for watching.